Let's begin again with a regular wave train. Only now it's 30 meters wide instead of 30 centimeters. Using this as our starting point, we're going to build up a fully realistic, multi-directional sea. The wave is produced by a row of wavemakers. In fact, one whole side of the tank is made of wavemakers. The paddles aren't connected together in any way, they're simply all obeying the same command signal. The drive signals to the individual wavemakers are monitored side by side on this screen. The display mimics the view you would get looking down from above the wavemakers. A high-speed microcomputer runs the tank under the control of a second computer. The single wave train in the tank shows on its screen as a vertical line or tooth, at a frequency of 1 cycle per second. Its size corresponds to the height of the wave. Now, let's change the direction of the wave train. The signal to each wavemaker hasn't changed, but we've introduced a delay or phase shift between adjacent wavemakers all the way down the line. Now the waves cross the tank at an angle of 20 degrees, but the wavelength and height remain unchanged. The display now clearly shows the phase lag between individual paddles. It's the size of this phase shift between wavemakers which determines the angle of the resulting wave train. Let's now reverse the phase shift. Now the delay occurs in the opposite direction, and the angle of the waves in the tank changes from plus to minus 20 degrees. Single wave trains like this are the basic building blocks for all the complex seas we make in the wide tank. Its angle is shown by the new position of the tooth on the screen. Let's now see what happens when we combine two wave trains. We'll add together the signals for the plus and minus 20 degree wave trains which we've already seen. This two-component sea is the simplest example of a three-dimensional wave spectrum. Now the waves have a finite length at right angles to their direction of travel. This important dimension is called the crest length. But to create a more realistic sea, we have to use more than two wave trains. The maximum number of teeth that can be used depends on the speed of the controlling computer and the number of wavemakers. The upper limit for this system is 75 teeth. They combine to produce an apparently random command signal. In fact, because the spectrum is made up of discrete wave trains, it isn't truly random at all. The conditions in the tank will repeat themselves indefinitely, with a typical period of about 3 minutes. This is of vital importance to experimenters who want to test scale models in realistic, but above all, repeatable conditions. The real sea is never as predictable as this.